Welcome back. Okay, the last thing we want to do is look at vertex form, and this time I am going to give you a description and you are going to write the function. So, before we talk more about vertex form, let's review the vertex is the minimum or maximum of the parabola. So, if the parabola opens upward, the vertex is a minimum because it's the bottom or minimum point. And then if it opens downward, the vertex is a maximum. It's the maximum height that the parabola reaches. So vertex form you can see right down here. And vertex form includes your vertical stretch or compression along with your reflection over the x-axis. And you can also see how your vertex has shifted left, right, or up and down based on h and k. So because we can see that translation, that's why we call it vertex form, because we can very easily look at the function and just see, based on these two numbers right here, where the vertex of the parabola is, which is often a very important piece of information. So we're going to practice writing functions in vertex form, given a list of constraints. So we're going to start with our parent function of x squared, and then we're going to reflect it across the x-axis, vertically stretch by a factor of 6, and then go 3 left. And we're going to create g. So they're telling us that when we write our answer, we're supposed to write g of x. Well, let's take these one at a time. Reflect across the x-axis. That's a vertical reflection, and so that means I write a negative sign in the front. A vertical stretch is also in the front. A stretch of 6 multiplies it by 6. Now I would have my x minus h. But am I shifting left and right? No, so I actually don't need to write a parenthesis. You can, it's not going to hurt anything, but I can just write it like this. Oh, I'm sorry, we are going to the left. I thought it said up or down. So we do need that parenthesis back there. And then 3 units left. Remember, it's the opposite. So when we're 3 units left, we're at -3. The opposite of -3 is +3. Close up my parentheses and square it. Now I'm not going to write a plus k because we're not going up and down. An easy way to check your answer is to just go ahead and graph it. Once you graph it, you'll see, is it flipped over so it opens downward? Okay. Is it stretched vertically, which means it's going to get real skinny? And did it move over to the left 3? So check for those things to know if you did it right. Now, it's not a guarantee, but it's pretty close. So take the time to do that. Let's try one more. Again, we're going to be starting with our parent function, and we're going to vertically compress this time by 1/3. We're going to go 2 units to the right and 4 units down to create g. So g of x, remember we start with any stretches, compressions, or reflections. It's vertically compressed by 1/3, so the 1/3 goes in front of the parenthesis. Then I do x minus h, remember the horizontal shift. So it is translated 2 to the right. That's a +2. The opposite of that would be -2. And now I go 4 units down, -4. Let's look at one word problem together, and then I think you'll be ready to get started on your homework. Here's the situation. It says on Earth, the distance d in meters that a dropped object falls in t seconds is approximated by the formula d of t equals 4.9 t squared. On the moon, the corresponding function is dm of t, 0.8 t squared. What transformation describes this change, and what does it mean? Okay, so we started with this, d of t, and we went to d sub m of t. What's the only number that changed? Yeah, this multiplier in front. And what does a multiplier in front do? Yes, it vertically compresses or stretches things. Did the number get bigger or smaller? Got smaller. So what happened is a vertical compression of, and now to figure out what it's being compressed by, we can divide 4.9 divided by 0.8. And I get 6.125. Wait, 6 is greater than 1. It's being divided by 6.125. Remember, a compression we always write in fraction form. So it's being divided by 6.125, which means it's being multiplied by 1 over 6.125. So I'm going to put 1 over 6.125 in my calculator, and I get 0.163. I'll round it to. It's a vertical compression of 0.0163. And I will write a note up here again of how I got that number. What I did was 4.9 divided by 0.8, and I got 6.125. And I did 1 divided by 6.125. And that's how I got the 0.163. Because remember, like dividing by 2 is the same as multiplying by half. Dividing by 3 is the same as multiplying by a third. Okay, so we figured out what the transformation was. Now the second part, what does it mean? Well, this is talking about the distance d in meters that a dropped object falls in t seconds. So on the moon, is the dropped object going to drop farther or not as far? You're right, it's not going to drop as far because there's less gravity on the moon. That's what it means. Okay, to summarize, what I'd like you to do is see if you can place all 4 of these numbers correctly within vertex form to write the new function that has been translated left, 3, up 3, stretched by 3, and then reflected across the x-axis. So go ahead, take a moment, pause it. All right, here's your correct answer. Reflected across the x-axis, vertical stretch by 3. Left 3 would be a +3, and then up 3 is another +3. So there you go, that's the correct format. Okay, if you have any questions, make sure you're stopping by office hours this week. But I hope that you find some of this to be review based on what we've learned about absolute value functions and parent functions. All right, I'll see you all in class.